What's good, everybody? I'm the G with a PhD, and you're tuned in to the Green Gorilla channel, the place where black men can express themselves freely, straight up, no chasing. This video is number 4 in a series of videos I'm doing on the philosophy of science. So if you haven't seen the ones that come before this one, go check them out so you'll be up to speed. In the last few videos, I discussed the ways in which science is both an epistemological and metaphysical endeavor. Science is epistemological because it utilizes a method that is supposed to help us obtain knowledge, true, justifiable beliefs. Science is metaphysical because it is supposed to explain the way the world really is and how and why it works the way that it does. Also, in the last video, I made a distinction between two philosophical positions, scientific realism and scientific antirealism. Scientific realism is the view that we should believe in things like electrons, protons, and neutrons. However, scientific anti-realism is the view that we should stop short of believing in the truth of scientific theories and content ourselves with believing what they say about what we can actually observe. But in this video, we're going to examine an event that took place during the late 16th and the 17th centuries, the Scientific Revolution. Prior to the Scientific Revolution, the primary school of thought was called Scholasticism, which was an arcane system of theology and philosophy taught in medieval European universities. The adherents of Scholasticism were called scholastics, and their belief system was based on Aristotelian logic and Christian dogma, and it formed a rigid cosmology and philosophy of nature. Among the doctrines expressed by scholastics was the idea that earth, air, fire, and water were the primary elements of the universe, and the belief that they each behaved according to their unique final causes. Another doctrine promoted by scholastics was the idea that the earth was the center of the universe, and that all the heavenly bodies, the moon, the planets, the sun, and the stars, revolved around the earth following circular orbits. They adopted this model of the cosmos from an astronomer and mathematician who lived around 150 AD named Ptolemy of Alexandria. Ptolemy systematically described the orbits of the heavenly bodies mathematically. However, the planets' motions in the sky are difficult to reproduce in this way because sometimes they appear to go backwards for a while, which is called retrograde motion. Ptolemy found that to get the theory to match up with observations, the motions of the planet had to be along circles that themselves revolved around the Earth, and this made the theory very complex and difficult to use. But then enter stage Nicholas Copernicus, a Polish Renaissance astronomer who shook up the scholastic establishment by proposing that the planets have the sun as the fixed point to which their motions are to be referred. Essentially, Copernicus argued that the Earth is a planet, which, besides orbiting the sun annually, also turns once daily on its own axis. This representation of the heavens is usually called the heliocentric, or sun-centered system, derived from the Greek helios, meaning sun. Copernicus's theory had important consequences for later thinkers of the scientific revolution, including such major figures as Galileo, Kepler, Descartes, and Newton. Copernicus probably hit upon his main idea sometime between 1508 and 1514, and during those years he wrote a manuscript usually called the Commentariolis, Little Commentary. However, the book that contains the final version of his theory, De Revolutionibus Orbium Celestium Libri Sexa, 6 books concerning the revolutions of the heavenly orbs, did not appear in print until 1543, the year of his death. Many of the scholastics that came into contact with Copernicus's work rejected it outright because it was counterintuitive and didn't seem to match up with experience. I mean, the earth doesn't seem to be moving, now does it? Likewise, the sun does appear to move. So one of the things that we'll come to find out in the course of this video series is that scientific theory seems to help us distinguish appearance from reality. Remember, this is one of the main aims of metaphysics, which is to discover reality apart from appearance. When Copernicus's book was published after his death, It included a preface by Andreas Osiander, a friend of Copernicus who had helped to prepare the book for publication, which declared that the motion of the Earth was a convenient assumption made by Copernicus, but which need only be regarded as a mathematical fiction, rather than being taken literally as asserting that the Earth was really in orbit around the Sun. This is an early example of the philosophical thesis of instrumentalism, according to which scientific theories need not be believed to be true, but rather should be thought of as useful or convenient fictions. Such a position is called an instrumentalist versus a realist view. The doctrine that the Earth is not at the center of the universe and that it is, in fact, in motion around the Sun was in direct contradiction with Catholic doctrine. And Osiander's preface did not prevent a controversy arising about Copernicus's theory. This controversy became quite fierce by the early years of the 17th century. And in 1616, Copernicus's book and all others that adopted the heliocentric hypothesis were placed on a list of books that Catholics were banned from teaching or even reading. It may be hard to appreciate why the church was so worried about a theory in astronomy, but heliocentrism not only conflicted with the Aristotelian picture of the universe and rendered its explanations of motion inapplicable, it also conflicted with the traditional understanding of the book of Genesis and the fall of Adam and Eve, the relationship between the earth and the devil on the one hand and the heavens and God on the other, and so on and so forth. The consequence of this was that if one were to adopt the Copernican theory, a great deal of what one took for granted was thrown into doubt. Hence, the need for a way of replacing the Aristotelian picture of the world with a set of beliefs that were equally comprehensive but more up to date. Now that's a lot to take in, so I'll stop here. In the next video, I'll be discussing Galileo Galilei and his unique contribution to the scientific revolution. Until the next time, my friends, peace.